Must have accidentally saved some work I did. So let's work through a Bayes theorem one and kind of have some additional questions as well. So we've got, and let me make sure, because I think I worked through a similar one. Yeah, so I did the lie detector one in that video. So this one has kind of steroid use in baseball, and we're given some information and ask some questions. So let's just kind of identify what we're told in the problem. So manufacturer claims that the probability a drug test shows positive given the athlete is using steroids is 0.95. So unlike maybe some of the Connect homework or some of even the stuff we've done in class, on the exam, I'll be very kind of obvious with these, and I'll always kind of use this terminology of given, right? So here, notice it says the probability a drug test shows positive. So the probability that the test shows positive given that the athlete is using steroids, right? I thought that was my phone for a second. So given that the athlete's using steroids is told to us to be 0.95. However, the probability that the test shows positive, given that the athlete is not using, so probability that the test shows positive, given that they're not using, is what, 0.01. And then we're told the probability that any one athlete chosen at random is using steroids is 0.15. Okay. So those are the three things that we were given. So the very first problem is, what is the probability the athlete's using steroids and test positive? So what we want to find is, what's the probability that they're using and the test comes back positive. Okay. So I'm looking for the probability of an intersection. So I go over here to my formula sheet. Looks like I've got some equations here. So these are kind of special conditions. This is when things are independent. This is an equation that holds when they're mutually exclusive. I don't have necessarily any information that these are independent or mutually exclusive. Here's where we would use Bayes' theorem. Also, it's a conditional probability. I'm looking for the probability of an intersection, right? A and B. Okay. So I'm likely going to have to use this multiplication rule. Right? So the reason why I kind of have two equations here is because, remember, it doesn't matter if I say A and B or B and A. Right? So occasionally, this first equation will work. Sometimes, if I try writing it differently, maybe, depending on the problem, I might have this conditional probability, but not this one. So it kind of depends on the information we're given, which one of these we can use. So we'll start writing this out and then try to figure this out. So the probability of an intersection is the conditional probability times whatever I'm conditioning on. So if I write this out, this is going to be the probability. Here's my A, here's my B. Now I'll blow this up in just a second. So the probability that someone is using, actually, sorry, I'm looking at this wrong. The probability of B, so the probability the test comes back positive, given that the person's using, and then we multiply that by the probability of whatever we're conditioning on, which is that they're using. So conditional probability. Oh, did I put B here? I meant A, didn't I? Times whatever I'm conditioning on. Okay. Now from here, I have these things, right? So what? Given that they're using, the probability the test comes back positive is 0.95. The probability they're using is 0.15. Okay. So that was simply rewriting the intersection as a conditional probability times what I'm conditioning on. Okay. Any questions on that? Now, possibly, if I had told you maybe I phrased the question, what's the probability that the test comes back positive and they're using, right? So now here's my A, here's my B. I try writing this out. Divide by, or not divide by, sorry. I run out of room and then I start to forget what I'm doing. Multiplied by the probability of whatever I'm conditioning on. So here that would be that the test comes back positive. I wouldn't have this conditional probability. So sometimes if I had phrased it differently, and you start writing this out, maybe I don't have that conditional probability, but I know that when I want the probability of intersection, it doesn't matter if I say A and B or B and A, right? It doesn't matter if I flip these. So that's why there's two equations that can work. And just sometimes one of those equations, I won't have this information, right? But the other one I did have. And usually I'm pretty nice in the way that I kind of order these in the problem. I order it so that when you write it down, if you write it down in that exact order, it'll have, you'll have those probabilities that kind of match up with that. Okay. Any questions before I keep moving here? Yeah.
The second way that you wrote it, would you be able to, if we didn't realize that you could just switch it around, could you use the conditional?
So, right, the problem is these conditionals, this is conditioning on the test. I was only given things that condition on the state of nature, right? So I can't actually use these probabilities down here because it's not, the order matters when it comes to a conditional probability, right? So saying something like, what's the probability that someone weighs over a certain amount, given that they're above a certain height, is different than saying what's the probability someone's over a certain height, given that they weigh a certain amount. It kind of, those conditional probabilities, the ordering matters, right? So we couldn't necessarily use anything that we were given. This is just something that we can't solve it this way. There's just no, which is why I'm usually nice and kind of give you the ordering in which, if you write it in that order, you would have the probabilities you could solve for. Yep. Any other questions before I keep moving here? So the next one is, what's the probability that the athlete is not using steroids and test positive? So we've got kind of another very similar example. For the sake of kind of time here, well, you can go through it. So what's the probability that they're not using and the test comes back positive, right? So once again, it's just the conditional probability times what I'm conditioning on. So if this is my A, this is my event B, using that formula, I know that I want B given A. So that's going to be test comes back positive, given that they're not using. And then I'll multiply by whatever I'm conditioning on, which here I've conditioned on event A. So the probability that they're not using. Okay. And then look at what I was given. Well, I have that given they're not using, the probability the test comes back positive. That's just 0.01. But was I given the probability they're not using? Not directly, right? But if I've got one of these setups where there's only two states of nature, the person's either using or they're not. So if the probability they're using is 0.15, what's the probability they're not using? Yeah, those things just have to add up to 1, right? They're the only two state of natures. So I have a little bit of work, but then I can find that missing probability. Okay. Questions on that one? 12, I believe. Yeah, so 11 and 12 are very similar here. Likely on the exam, if I asked one of these, I'd probably only ask one. I wouldn't kind of give you two of the same one, right? But I can almost guarantee you that I'll kind of have a setup like this where I give you some conditional probabilities and then ask you to find the probability of intersection. Okay? 13 is a little bit harder, right? So 13, I say, given that the test comes back positive, so given the test comes back positive, what's the probability that they are not using, right? So that's what I'm looking for. You go to my formula sheet. Now, maybe I try to write it out like this, right? I've got a conditional probability. I can rewrite that as the intersection divided by what I'm conditioning on, right? I'm just rearranging that multiplication rule kind of equation. Now, if I write this out, I'll realize pretty quickly, if this is my event A, this is my event B, the probability that the test comes back positive, I wasn't given anything remotely close to that, right? I was given some conditional probabilities. I was told the probability of the states of nature. And so a lot of times when you get to a problem like this, if you're looking for a conditional probability, if you just try to write it out using that multiplication rule, you're not going to have that information, right? And this is because what we're looking at is the outcome of the test, right? And so given the outcome of the test, what's the probability of different states of nature? That's going to be this idea of Bayes' theorem, right? And so I'm going to have to actually go down here and kind of use Bayes' equation, Bayes' theorem equation. Right? So I'm just going to write this out in the context of my example. So instead of A and B, just to make this easier, here's my state of nature I'm interested in, and here's my E, my outcome of the test. So all I'm going to do is write this out in the context of my example. So the probability of S, so the probability of not using, times the probability of what? E given S, so that the test comes back positive, given that they're not using, divided by, and here just to save myself a little room, notice this numerator is the first part of the denominator. So it would be the exact same thing down here, right? So whatever this is, you could rewrite, write this exact thing out. I'm just going to kind of use these little quotations to kind of indicate I would write the same exact thing here, but just save myself a little space. Then I add to that the probability of S complement. Well, if my event S, the state of nature I was interested in, is that they're not using, S complement would be what? Yeah, right? Just the other state of nature. And then multiplied by the probability of E. So my E, the outcome of the test that I saw was that the test came back positive. Given S complement, we just said S complement is that they're using. So from here, it's just a matter of plugging things in, right? So I had the probability they're using is 0.15, probably they're not using is 0.85. So 0.85, 0.85, and then this was 0.15. Given that they're not using, the probability the test comes back positive. This was 0.01. And then given that they're not using, oops, sorry, did I look at this wrong? I did. This wasn't 0.01, this was 0.95. And then given that they're not using, the probability the test comes back positive. This was the 0.01. Oops. So what I did there was, this is the probability I wanted to find. I wrote out Bayes' theorem in the context of my example, and then given the information that I was given, I kind of plugged in the probabilities that I know. Okay. Yep.
Use that Bayes theorem if you can't find.
Oops.
If you can't find
So when you use this, I guess if you had, so let's say I had written this out using that multiplication rule. Right? So I know that the conditional probability is the same as the intersection, so that they're not using, and the test comes back positive. Divided by the probability of what I'm conditioning on. So if I had written it out this way, I'll very quickly realize I wasn't given any intersections. I wasn't given just the probability that without any information that the test just comes back positive. So if you try writing it out this way, you're like, I don't have these probabilities. That's a good indicator you can use Bayes' theorem. Ahead of time, without writing it out like this, I mean, first of all, the structure of the exams are similar. So you'll kind of know around where if I see, in the middle of the exam, I have to find a conditional probability. It's probably a pretty good chance I have to use Bayes' theorem. But also you're thinking about any time that the probability you're looking for, if you're conditioning on the outcome of any test, that's a good indicator that you're using Bayes' theorem, right? You're given that the test comes back a certain, result, then what's a probability of a certain state of nature, that's a good indicator you're looking for Bayes' theorem. Any other questions on that? One other wrinkle I could throw at you there is, let's say this was the setup, right? Same type of problem, but instead, maybe I had told you, let me just get another piece of paper. maybe instead what I had given to you was, given that they're using, the probability of the test comes back negative. And let me make sure this lines up with what we were doing earlier. So given that they're using, so maybe I told you this was 0.05. Right? So then when you go to, you'll start to try to plug things in. Well, you want, given that they're using, the probability the test comes back positive, but you were only told that given they're using, what's the probability the test comes back negative. So you wouldn't have had this piece of information. Right? But how could I found this probability or this piece of information? Well, remember, we said anytime I condition on the same state of nature, the conditional probability for these two outcomes of the test should add up to 1. Right? So inherently, if you tell me that given someone's using, the probability they see a negative test result is 0.05, well, then conditioning that same thing, given that the person's using, the probability they see a positive test result would just be whatever is remaining. And now I would have that missing probability that I could plug in. Right? So that's the only additional kind of wrinkle that I could maybe throw at you on one of these Bayes theorem examples. Okay. Yep.
So is the state of nature always going to be the thing that's given? Like,
so in these types of problems, the information that I give to you, yes, the conditional probabilities you'll be getting, you're always conditioning on the state of nature. Because usually what we're interested in finding are the probabilities of, given a certain outcome of the test, different states. So this is usually what you're trying to find. This is going to be the information you're given. So you're typically given conditional probabilities where you're conditioning on the state of nature. Yep. And then you want to find the probability of those different states of nature given, right, or conditioning on the outcome of the test. Yeah, so you'll always typically be given probabilities where you're conditioning on the state of nature. Any other questions? This one. Okay. All right, so